All right. I would say we get started with the next talk from Michael. And it's about a topic which I'm very excited about because I've heard like recently only about it. So we are now diving into terminology and VCL. Thank you.
Excellent, thank you. Okay, so I'll make that go away. Okay, so I'll dive in quickly. I've got a lot to cover. These slides have been growing. I haven't had time to shrink them down, so I'll try and get through everything. So I'm Michael Lawley. I'm a research group leader from CSIRO. CSIRO is Australia's national science agency. I work in the digital health program. We do semantics, interoperability. I'm the lead on Onto server, the FHIR native terminology server. I've been working with SNOMED CT for about 15 plus years, and some of the sort of deep stuff there, so ECL, post-coordination, OWL, and description logic. So that's my background, and that's what I'm sort of bringing into this presentation, which is about essentially taking the idea of SNOMED's expression constraint language, which is essentially a query language for SNOMED, to FHIR CodeSystems. So for people who've lived in SNOMED land, they like ECL, brings a lot of power. It also, through implicit value sets, gives you a lot of dynamic flexibility for working with terminology in FHIR, but you lose that in all the other, pretty much all the other code systems in FHIR. And really what led into this work was that there were some threads on Zulip with people saying, how do I do this with a FHIR value set? So Josh asked a question about RxNorm. How do I start with acetaminophen and find the branded packs that contain that? And that sort of requires navigating through the model that underlies RxNorm, and you can't do that navigation in a FHIR value set. You can constrain on values of properties, but you can't sort of navigate through properties. So this is one of the kinds of things he wanted to know, all branded packs containing acetaminophen. And then there was another thread, happened to involve Josh again, looking at terminology-powered search. So you want to search your FHIR server, you want to match on sets of codes, but you've got to decide or define what those codes are that are of interest. And so you do that with either a list of codes, so you can do a code :in equals and then a list of codes. But often you want to specify it as a query, like all the medications that contain acetaminophen, or things that have a particular label, or that sort of thing. So how do you do that? We have to actually create a value set and then give that a URI, put it in the server, refer to that, and you can say code :in equals value set URI. That's a lot of work to do, especially if you're trying to do some kind of dynamic query, something on the fly. But also you might not have right access to the FHIR server to define that value set in the first place. So we want to use that value set terminology mechanism. We want to push all the terminology stuff to a terminology server, not have our FHIR server have to understand all the semantics of all the different code systems. And we want to leverage the existing FHIR path or search syntax to use all of this. Well, here's something we prepared earlier over in SNOMED land, with SNOMED's expression constraint language. So this is a language that was that sort of evolved out of SNOMED's post-coordination language, so that's where the syntax comes from. But it allows you to do all the sorts of things that you want to do with a code system. It allows you to traverse the hierarchy, going either up the hierarchy or down the hierarchy. It allows you to match on or constrain on values of properties or attributes. It allows you to navigate through attributes. So if you're starting with a the set of all procedures. Starting from a particular place, you can say, well, what are all the sites involving that these procedures involve? And you can search on other properties that exist in SNOMED, which are not really relevant to FHIR. And you can do reference set membership. So reference sets in SNOMED are analogous to value sets in FHIR. And so you can sort of traverse from your expression to say, is my code or is the value of my attribute a member of this value set? So these are the sorts of features that we want to bring across into our solution space. And this is exposed in FHIR at the moment through two mechanisms. One is the filter property called Constraint. So in a value set definition, you can say include filter equals constraint operator equals, and then the value is an ECL expression. The other way you can get access to this is through an implicit value set. So you see here this sort of syntax. This is identifying an implicit value set, and you just drop your ECL expression in here. So you don't need to create anything on the server. You can just put your expression there on the end in this sort of fill out the template, and then you can use that directly in your FHIR search. So you can say search code : in this URI, and that's defined the value set already for you. So that's really handy. So what if all code systems had an ECL-like thing? Well, that'd be really great. So that brings us to where we are now. Well, almost. So there was another conversation that led to a FHIR ticket. This was around term filtering. So one of the things you can't do in a value set at the moment is actually constrain on the descriptions or the designations associated with a code. So this was another gap. There was a discussion at the May 2022 Connectathon, and there was a set of outcomes, and the key thing was a URL-friendly syntax for ValueSet.compose that uses a subset variant of ECL, and so that's where we went. So the goals were easy to write and read, compact, URI-friendly. So one of the key goals is that we want to be able to use this in these implicit value set URIs. So we don't want to put in characters like hashes or question marks or ampersands, because then we'll have to percent encode them, and then they won't be readable. But we also want to sort of not force white space, so that takes away. It sort of says in a design space, well, we don't want to have keywords as our separators for ands and ors or things like that. So we use punctuation for that. We need to deal with complexities of code systems, because basically any string of characters can be a code, except for the ones that begin and end with white space. So codes can contain white space, they can contain all these other horrible characters, so we need to have syntax that works with that. We had some non-goals, so parity with ValueSet.compose was not a goal. We have to be able to do everything you can do in a compose also in this language. Neither was parity with ECL or even ECL compatibility. So it was just a starting point, because it's a sort of known familiar syntax that pointed us in a direction. I did a couple of things. I looked at previous constraint language or query languages for code systems. I looked at things like TQL and OSQL, and there's a whole raft of them. None of them were particularly useful. Often they were very database-like languages. And then I went and looked at, well, what are the real-world requirements? What are the priority things that we need to deal with? I grabbed about 15,000 value sets that have somehow been uploaded to our sandbox terminology server. 5,500 had a filter expression, and then these were the different operator types that I found in those value sets. This is not, and some contain multiple of these, right? So that sort of says, well, hierarchy traversal is really important. these are basically, attribute equals value type things. So this is attribute has a value in a list of codes. So it's just slightly simpler way of doing this. More hierarchy traversal, and then some sort of outliers. So regex on codes, which is for some code systems a way of doing hierarchy traversal. Hello ICD. Exists, so does the property have a value or not? And then this kind of weird is not a. And R5 contains some more operators that didn't occur in any of those things. They're still in scope. So the intuition around VCL, if you don't know ECL, and you're just coming to this from ValueSets, so you understand there's the compose, include, or exclude filter, is that we have a property, an operator, and a value, and that's how it translates into the language. We put a colon immediately before the operator name in the syntax. That just helps with the parsing. That's basically it, and we've put in some some syntax for traversing the hierarchy. So less than means descendants of, double less than means descendants or self. So the code or the descendants, which is the same as ISA, and then greater than for going up the hierarchy, and then there's some others, less than exclamation mark for just immediate children, that sort of thing. For and or, we have comma and semicolon because they're nice and reasonable punctuation, and we don't have to put white space around the words. And or might show up as code, so that would be really confusing. We have some quoting rules, so where you have string values, you put double quotes around them. Where you have non-trivial codes, you put single quotes around them, and there are escaping rules for the quoting. And where you have URIs, you put angle brackets around them, so the less than, greater than. And then there are a couple of extra features that you can't do in a ValueSet.compose, so the path navigation stuff, and then the term filtering. This is not actually in the current proposal yet, and if I have time, I'll talk about why it sort of got stuck. So some quick examples. So we've got the code itself, matches the code itself. Double less than is the code or any descendants of it. We've got wildcard, so star means anything. And then we've got these sort of star colon parent equal b. So this is all codes such that, so you can read the colon as such that. So any code that has a parent with a value b. If you have a code valued property, parent is a code valued property, but you have another code valued property, it's the same sort of syntax. This is a Boolean valued property, so inactive equals true, and so on. And then this is, this matches B, the code B, if its code prop has a value of C. Remembering that, properties here can be multi-valued, so it has at least the value C. And then we have the sort of the navigation. So this is all the values of the code prop for this code B. We can combine things together. So this takes all the descendants of B and gets their code props. And we can do multi-step navigation as well. And we can also constrain values in the context of navigation. And so that all those sorts of features naturally extend. And then here are some examples that do the filter stuff. So give me any code where it has an ingredient. So there is some value for the ingredient property. Match all codes where the code itself matches the regular expression in the quotes. Or match a code prop that's in that list of values. I don't expect you to read the grammar. It's going to change. I will have to speed up. So this is how you might have written something with the current details. This is the corresponding expression. Any code where scale type equals doc. This is the scale type equals doc. Actually, the star colon is kind of redundant or optional, so you can leave it out and just say scale type equals doc, and there's an implied star colon there. And we're proposing that we add a new filter type that's defined for all code systems called VCL, and you can just put the expression in there. So it's analogous to constraint for SNOMED. So some examples. So this example here, you've got the star column version as well. All the things that consist of something that has an ingredient equal to 161, which is acetaminophen. If you also want to make sure that they have oral dose form, you can do a conjunction. So that's what the comma is. So that also having oral tablet dose form. Or maybe you want to know what are the available dose forms for these products. So that you can populate a drop-down list and let it someone choose. Then there's a value set membership. So in ECL, the syntax is something like this, with this little caret and then the identifier for the reference set. In VCL, it's just the :in operator and then the value set URI in the angle brackets. And so you can do that in SNOMED in a value set. You can't do it in other code systems, but this gives us that. Now I'll quickly go through some of the open issues. So the designation filtering, that was one of the things that needed to be solved. I haven't done that yet. This is what it would look like in ECL. It's this double curly brackets, and it's all a bit ugly and not very URI friendly. And you know, this D makes sense in SNOMED land. It doesn't really make sense for VCL. So I'm seeking input on what people might suggest is useful there. The other thing that's a bit weird about this is that this is not saying it equals this value. It's saying it matches that value, and the matching is word prefix any order matching. There is no way to say it's exactly this unless you use the regex syntax. Is that really what we want? This is what I've proposed as the URI, implicit URI syntax. So it's just the code system URI, this little bit of separator stuff, and then the expression. Should this work for SNOMED as well? And what about code system supplements? So can you use the code system supplement URI here and implicitly use the supplement as well? The alpha implementation we've got in Onto Server doesn't do a bunch of the modifiers yet. A couple of them, I'm not really sure they're necessary, but we'll need to just add them all in. It's a fairly straightforward thing. We don't do multi-code system, so this language only does a single code system, and there's the question around code system supplements. So where are we with FHIR 36651? There's a proof of concept implementation, so you can go and play with that at this URL. There's a thread on Zulip. There's obviously the ticket itself if you want to comment, but there's a thread on Zulip. It's already had some traffic this week. And you can talk to me after this or on Twitter or elsewhere. So Q&A.
Awesome. Thank you so much, Michael. Yep.
So could you talk a bit about what would be the primary use case of this VCL? Would it be mainly for populating user interfaces, or would you also provide it as well as part of a FHIR profile for validation operations?
Yeah, so I mean, you can use it anywhere. You can use ValueSets. So but where we see ECL used is sometimes in value set definitions inside profiles, and you do it that way because you want to put all the metadata around the value set to say versioning, why you're building it, who's maintaining it, and all that kind of thing. But really where the key value lies is in dynamic user interfaces. So for example, if someone selected a procedure, you may want to have allow them to refine the body site to just things that are more specific than the one that's already mentioned in the procedure. Or similarly, you might want to allow them to, they've selected a drug, what dose forms are available. You may want to then populate something dynamically there. And the other key use case is in the analytics space where you're doing dynamic queries over your data for interactive use or what have you. And so you're building these implicit value sets on the fly, interrogating your data.
Is there in your current reference implementation? Is there already support for, or is support planned for the validation operation in combination with VCL?
Oh yes, of course. Yeah.
Already.
So onto a server supports the validate operation on any FHIR resource, but all the terminology validation goes through onto a server itself. So it's like providing the -TX option to the other ID publisher tools and so forth, and pointing it onto a server, but you can just do it directly in there.
All right. If you have any other questions, I'm sure Michael's happy to answer that over lunch, and that's
Absolutely.
where we're heading now. Thank you.
Okay, thank you.